Okay, this tutorial is working out some problems with the vertex graphing form of the quadratic equation, and that's section 3.5 in Math A30. So I've got a couple of them written out here, and the first one is, given that we have this form here, y equals a times x minus 1 all squared minus 2 passes through the point negative 2 and 21, find a, period I should have had there. What is the vertex point and the axis of symmetry, and what is the concavity of the equation? So I've added some extra questions in there that just to see if you can analyze the equation. So we can answer, first of all, what is the vertex point? Well, the vertex point is PQ. So the vertex is equal to PQ. And remember that the general form always has that negative sign in the brackets. So that means that you have to, don't put -1 for your P, put 1 for your P and -2 for your Q. So it's 1, -2. That's your vertex point. Then it asks us, what is the axis of symmetry? Well, we know from the last tutorial that the axis of symmetry is just x equals P. And in this case, x equals 1. And finally, we have to find out the concavity by looking at what the value of a is, if it's positive or negative. In our case, we can't tell because we have to solve for a first. So in the first step, we're going to try to solve for a. So in the first step, we have to plug in the point values and solve for a. So plug in the point given into the equation. Well, let's say the quadratic equation. And solve for a. Okay, so we're going to do that. So we know that a is 21, or sorry, not a, that y is 21 and x is -2. So let's plug those in. So y is 21 is equal to a, which is blank, and x is -2 minus 1 all squared minus 2. So let's work this out. 21 is equal to a, well, that's -3 all squared minus 2. To do the square first, 21 equals -9 a, or sorry, positive 9. What am I doing? -3 times -3 is positive 9. A minus 2. Have to add 2 to both sides. So adding 2, we get 23 is equal to 9a. So we're going to get a being a fraction. So we have to divide a. Divide 9 here to get a, I mean. So this would be a is equal to 23 over 9. Okay, now one thing I didn't mention in the last tutorial is that the values of a, I mentioned that if they're positive, it goes concave up, and if it's negative, it goes concave down. But I did not mention about the size of a and what the size of a tells us. So first thing we can say here, because it's positive, we have a value of an upward quadratic equation. So it is concave up. Okay. And that's the case in our case because this value is positive. We had a positive 23 divided by an positive 9, so we had a concave up. And the one thing I didn't mention that I'm going to mention here now is that whenever you see that a is greater than 1, okay, you have narrower than normal, a narrow equation or parabola. If A is less than 1, so like a quarter or a half or something like that, you're going to get a parabola that is wider than normal. And of course, if A equals 1, I better check my field of view here. Well, you have normal width of a parabola. And we'll look at that in more detail later on. Okay, so we're going to go on to our next question here that I have on the next sheet.